Okay, so we are Introduction to Statistical Learning. We're in the conceptual questions of Chapter 4, and we are on Question 8, which is right here. So we have a data set, and we've divided it into training and testing partitions. And so we tried two procedures to analyze it. So we're classifying the observations in this data set. And so first we use logistic regression, and then later we're going to use k nearest neighbor with one nearest neighbor where k equals 1. And so when we use logistic regression, we get an error rate on the training data of 20%, and then we get 30% error rate on the test data. And that, again, that's for logistic regression. And then when we go to k nearest neighbors, we get an average error rate, so averaged over the training and test data of 18%. Which method should we prefer for classifying new observations? Okay, and why? All right. So so this question just kind of actually feels a little bit like a trick question, a little bit, because what it relies on is your kind of understanding of how k nearest neighbors works. So in k nearest neighbors, there's no such thing as well, there's no training error rate, right? In k nearest neighbors, we train the algorithm on the training data, and the training data is training data because we already know the categories of each data set, right? So or of each data point. So we don't have a training error rate. So then we have to figure out, what does it mean if the average error rate, and I'm just calling it here epsilon bar, what does it mean to have an average error rate of 18%? Well, let's just use first algebra. So the average of the training error and the test error for k and n, right, it would be this, right? So we have the average of the training rate, or training error rate and test error rate, okay? And so then if we want to solve for test error rate, we need to multiply over by 2. And again, there is no training error rate. So we just have the test rate, or we just have the error of the test rate is twice the average error rate. Okay. And so if the average error rate is 18, then it's twice that, and that equals 36%. So 36% error rate from the k nearest neighbors where k equals 1, that is greater than the 30% error rate that we had with the logistic regression on the test data. So we should prefer to use the logistic regression in this case.